All right, in our last section, we talked about graphing basic sine and cosine functions. We talked about amplitude and period, right? So let's do a few review questions, and then we'll talk about what happens with more translations. So in the first one, y equals sine of x, we know hopefully now that our amplitude is 1, so it's going to go up to +1 and down to -1. That our period, our b is 1, so our period is 2 pi, so it's going to go from 0 to 2 pi before it makes a full cycle. So half of 2 pi is 1 pi, half of 1 pi is pi over 2, so pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 will be my units along the x-axis. I know that sine always starts at 0, and then it is going to go up to 1, it is going to go down to 0, it's going to go down to -1, and it's going to go up to 0 again. Completing its full cycle would look something like that, right? Okay, so then look at the second one. How is that second equation different than the first one? And then how does the graph look different? So y equals 2 sine of 3x. Well, that 2 tells us the amplitude now isn't just a 1, it's a 2. It's going to go all the way down to -2, all the way up to +2. The 3 in front of the x tells me that the period now is going to be 2 pi over 3. So from 0 to 2 pi over 3 is going to be a full cycle this time. If I want to cut it in half, 2 pi over 3 divided by 2, or times 1/2 would be pi over 3. Dividing that by 2 would be pi over 6. So I have 1/6, 2/6, 3/6, and 4/6 all reduced for my 4 different units along my x-axis, right? All right, sine starts at 0. This time, because the amplitude is 2, we're going to go all the way up to 2. We're going to go down to 0. We're going to go down to -2. We're going to go up to 0 before it completes its cycle. So essentially, if this were on the same graph as the first one or the same x and y coordinate, it would be squished a little bit and it would be taller, right? Because we've kind of drawn our own on a new x and y coordinate, it kind of looks like it's the same size, maybe just a little bit taller. But if you imagine, it's going to be kind of squished a little bit because of that period change. All right, so then look at the third one. We still have a y equals 2 sine of 3x, right? And so the amplitude is still 3, the period is still 2 pi over 3, and so without anything else, my graph would look like it is now, the blue graph, right? But this one has a +4 in the back. What do you think that +4 in the back will do to my sine graph? Well, hopefully you remember from doing parabolas and even absolute values, even some square root graphs, that constant at the end, what that does to our function is it translates it up and down. Because it's a +4, what this graph is going to do is it's going to, let me take my graph, and it's going to shift it up 1, 2, 3, 4. So now my new graph looks like this. This would be my final 2 sine of 3x +4 graph. That +4 in the back is going to shift it up 4. If it were a -4, it would shift it down 4. So we're going to talk about that a little bit more today in this section, about that translation, vertical translations of sine and cosine.